Before start the practical, let's see an introduction in a nutshell. Soil water retention curve is the relationship between the water content and the soil water potential. This curve is characteristic for different types of soil and is also called the soil moisture characteristic. Texture, soil structure, and bulk weight are the main factors that determine the curve. Among them, the greatest impact is soil texture. Thinner soil particles increase the surface area and the number of small pores. The structure and bulk density impact on soil pore conditions, meanwhile affecting the curve. The soil water characteristic curve describes the functional relationship between soil water content and the metric potential under equilibrium conditions. Different soils have different characteristic curves. Soil water potential is the energy status of the soil water. Moisture content of the soil is the amount of water in the soil. Further, there are three critical levels of soil water can be identified in the moisture characteristic curve. They are saturation level, field capacity level, and wilting point. You can see the graphical illustration of these characteristics in this slide. There are three main types of soil water. They are gravitational water, capillary water, and hygroscopic water. And these terms are defined based on the function of the water in the soil. Gravitational water is free water moving through soil by the force of gravity. At the saturation point, all pores are filled with gravitational water and quickly drains out of the larger pores under the influence of gravity. After removing gravitational water, the soil moisture becomes to field capacity level. At this point, soil is holding the maximum amount of plant available water. The form of water at the field capacity is capillary water. Capillary water is held in pores that are small enough to hold against gravity, but not so tightly. They are bonded through the adhesion and cohesion forces. At the wilting point, the hygroscopic water are not available to the plants, and they form as a thin layer around the soil particle, which is tightly bonded to the soil particles. So, in here, you can see the required energy status to remove water at different level of soil moisture. At this saturation, no energy is required to remove water from the system because they drain out due to the gravitational force. At the field capacity, we have to apply around minus 340 cm suction to remove the bonded water molecules from the system. Next, at the wilting point, we have to apply around minus 15,000 cm suction to remove water molecules because at this stage, water molecules are tightly bonded to the soil particles. Now, we are going to find the relationship between water potential and water content using a model apparatus which is mentioned in the slide. In here, water is removed from the saturated soil by applying a negative pressure using a pressure difference in the rubber tube. Procedure. Here is the brief procedure which can be segregated into 6 main steps. Step 1. Fill the apparatus with water. This is the model apparatus of the practical. At first, you have to fill water from the burette side of the apparatus until the apparatus becomes steady. as no air bubbles are trapped within the system. Here, raise and lower the burette during the period of filling water. Step 2. Prepare the apparatus for use. Here we raise the burette. At this time, water bar at the side of the funnel is getting increased. You have to maintain the situation until you obtain a 2 cm raised up water volume above the perforated plate. Then add a filter paper on top of the perforated plate. Next, lower down the burette until remove all the water which filled into the funnel. Then, gently pat on the filter paper by using a glass rod and seal it to the funnel. Next, place a membrane filter on top of the wetted filter paper. Then, add 50 grams of soil on the membrane filter evenly. Thickness of soil layer should be 1 to 2 centimeters. Again, raise the burette level. Then you can see the soil in the funnel is being wetted with the water. You have to continue the process until soil becomes saturated from water. You can identify a thin water layer above the soil stratum at the saturation. Then close the stopcock of the burette and raise the burette and funnel as high as possible. Step 3. Take the initial parameters. Next, open the stopcock and let the water level in the burette become steady. At the steady point, you have to take the burette reading as V note. Now, record the distance from the datum level to the center of the soil sample as H note. Step 4. Apply different levels of suction and take V and H values. Lower down the burette as to change about 2 cm of the reading and allow it to become steady again. Record burette reading V1 and vertical distance to the center of the sample and denote it as H1. Repeat the lowering process and record the burette readings and heights at several times. Step 5. Calculate the bulk volume of the sample. Measure the inner diameter of the funnel. And the height of the soil sample. Final step is calculating oven dry weight of the sample. Remove the soil sample after all the gravitational water drains out. Then oven dry the sample and take the weight. Calculations. Here are the readings that we obtained. And we have mentioned the formulas to calculate the bulk volume and weight of the water in the sample at the last step.